Why is spread spectrum modulation essential? 4. Robust communication. Imagine trying to have a clear conversation in a noisy room. That's similar to what electronic signals face when they travel through busy or interference-filled environments. Spread spectrum modulation is like giving your signal a loud, distinct voice that can be heard over the noise. It is a technique where the signal is spread over a wider bandwidth than the minimum needed to send the data. This spreading is done by combining the original data with a special code called a spreading code or pseudonoise sequence. Both the sender and receiver know this code, which helps them communicate effectively. The result is a signal that looks like random noise to anyone listening in without the right code. Only the receiver with the correct code can pick out and recover the original data. This process is called despreading. The main reason spread spectrum is so important is because it makes communication more reliable. When signals are spread out, they are less affected by narrowband interference like noise or jamming. Even if part of the spectrum gets blocked or disturbed, the rest of the signal can still be recovered. This is especially useful in places with high electromagnetic interference or when many users share the same frequency. Another big advantage is security. Since the signal looks like noise, it's hard for unauthorized people to detect or decode it without knowing the spreading code. This makes spread spectrum perfect for military, industrial, and personal wireless uses where keeping data safe is a priority. Spread spectrum also allows many users to share the same frequency without interfering with each other. Each user gets a unique spreading code, so their signals can be separated at the receiver. This technique is called code division multiple access, and it's used in cellular networks and wireless local area networks. There are two main types of spread spectrum techniques. One is frequency hopping spread spectrum, where the carrier frequency switches rapidly among many channels following a pattern. The other is direct sequence spread spectrum, which multiplies the data by a high-speed pseudonoise sequence, spreading the signal across a wide frequency range. Both methods help make signals more resistant to interference and improve security. Spread spectrum is used in many everyday technologies like Wi-Fi, Bluetooth, GPS, and cellular phones. In analog signal processing and control systems, it can also reduce electromagnetic interference in clock signals, helping electronic devices meet emission standards. To sum up, spread spectrum modulation is essential because it makes communication more reliable, secure, and efficient. It helps signals get through noisy environments, keeps data safe from prying eyes, and allows multiple users to share the same space without chaos. That's why it is a cornerstone of modern wireless and wired communication systems, supporting the goal of delivering dependable and secure signal transmission.